Hey there everybody, my name is Megan Cato, and today I'm presenting about how an abiotic factor, specifically low soil moisture, affects plant species composition. I'll focus on common yarrow, Achillea millefolium, a medicinal herb that is well adapted to dry environments. I'll explain how its adaptations allow it to succeed in ecosystems with limited water and how changes in moisture availability could affect both yarrow and the surrounding plant communities. Abiotic factors are non-living parts of ecosystems that strongly influence which plant species can survive and thrive. Factors such as water availability, temperature, and nutrient levels act as filters that shape plant community composition by favoring species with specific adaptations. The abiotic factor I selected is low soil moisture, which often results from limited precipitation and fast-draining soils. Drought stress limits plant growth by reducing photosynthesis, nutrient uptake, and cellular function. Only species with drought adaptations can persist under these conditions. Common yarrow is a perennial herb native to temperate regions of the northern hemisphere. According to the USDA Plant Guide, it frequently grows in dry meadows, roadsides, and grasslands. Yarrow is well known for its medicinal uses, but it also plays an important ecological role in drought-prone ecosystems. The primary science article I used was a 2025 study published in Scientific Records by Roselia Adel, I just butchered that name, and colleagues. The researchers examined how yarrow responds to different soil moisture levels. They found that yarrow had maintained growth and physiological function even under reduced water availability, although drought stress influenced its phytochemical composition. Yarrow has several physical adaptations that reduce water loss. Its finely divided leaves decrease the surface area, which helps limit transpiration. The USDA Plant Guide also notes that yarrow has a spreading and resilient root system that allows it to access available soil moisture and survive drought conditions. Physiologically, yarrow is adapted to use water efficiently. According to Bistagani and colleagues, medicinal plants like yarrow can maintain photosynthesis and cellular stability during drought by adjusting metabolic processes. These physiological responses help prevent irreversible damage during periods of water stress. These adaptations allow yarrow to survive in environments where water limits the success of many other species. During drought, less adapted plants may die or fail to establish, reducing competition. This allows yarrow to persist year after year and remain a stable member of the plant community over time. If an external influence, such as climate change or altered land management, increased precipitation in this ecosystem, soil moisture would rise. This would reduce the drought stress that currently favors drought-adapted species like yarrow. With increased soil moisture, yarrow would likely continue to survive, but it may become less dominant. Faster-growing, water-demanding plants would outcompete it for light and nutrients, reducing its relative abundance within the plant community. Increased moisture would allow species that are less drought-tolerant to establish and persist. This would increase plant diversity and lead to denser vegetation, shifting the overall composition of the plant community away from drought-adapted species. Changes in abiotic factors like water availability and soil moisture affect not only ecosystems but also the availability of medicinal plants such as yarrow. A decline in drought-adapted herbs like yarrow could impact traditional harvesting, pollinator support, and overall ecosystem function. In conclusion, low soil moisture is a powerful abiotic factor shaping plant species composition. Yarrow's structural and physiological adaptations allow it to succeed in dry environments. Changes in water availability would shift competitive dynamics and reshape the plant communities. These are the sources These sources provided the scientific and ecological information used in this presentation. Thank you for listening, and bye for now.